Hello everyone, welcome to ABR Tutors. Today I will be talking about a very often confused topic, and that is the topic of molarity versus molality. Okay, and you might not have even noticed it when I said it, but the difference here is we have an R versus an L. That is the only difference between these two words. And so oftentimes you have to be careful when you're listening to a professor or a researcher saying this because those two words can often sound very, very similar. So what is molarity and what is molality? To add to the confusion, molarity is represented with a big M, and molality is represented by a little m. Why did they do this? I don't know. Nobody asked me when they made it. Okay, so we're over here. Molarity is equal to the moles of a substance per 1 liter of solution. Okay, and then molality, here I'm going to zoom out here. Molality is equal to moles of a substance per 1 kilogram of solvent. Okay, notice the differences here. So molarity is how many moles per 1 liter of solution. Molality, how many moles per 1 kilogram of solvent. Okay, again, very similar, slightly different. So let's go through an example here to show some of the differences. So let's say we have a bucket of water. All right, bucket of water. Okay, and for ease, we're going to say this water adds up to 1 liter. It's 1 liter of water. Now inside of here, I'm going to put some little glucose molecules. All right, I'm just going to draw glucose as pink circles. Lovely little glucose here. Okay. Now, we need to remember that when we're talking about moles, 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay? So let's assume I put in that many molecules of glucose into 1 liter of solution. All right, so what is our molarity? So remember, I'm asking molarity, so that's this one right here. So we're looking for how many moles were in 1 liter. Well, thankfully, we had 1 liter solution, so that stays the same. And I said I put in 6.02 times 10 to the 23rd molecules. So I put in 1 mole per 1 liter. So our answer is we have 1 molar glucose solution. Okay? Now, let me explain what molality means. Okay? So again, I'm going to draw out a little bucket of water. And for ease, it's going to mean the same thing. Okay? I have glucose molecules again. Again, I have 6.02 times 10 to the 23rd molecules of glucose in this bucket. And for everybody's sake, I am not going to draw that many. Okay, so here is the 1 liter. Now, let's pretend I take out all of these molecules, okay? So I'm going to go ahead and I erase, okay, I'm going to erase all of those molecules, and they are now gone. And I'm going to refill this in with water here. Okay, but as you can imagine, it doesn't just form little holes here where the glucose used to be. That's not how water works. Water is going to go down and immediately fill those holes. Okay? So what's realistically going to happen is our water level is going to actually fall down to slightly less than it was before. Okay? So you can see we lost a little bit of water. So now I'm going to write our new water. It's no longer that. Our new level of water is 0.9 liters. Okay? So, if we have 0.98 liters of water, and we know for water, for H2O, 1 liter equals 1 kilogram. Okay, that's just a nice conversion that happens with water. Okay, so we have how many moles? Well, we know I had 6.02 molecules of glucose that I took out. So we're going to imagine they're all kind of just floating above here. They're not on the water, they're just taken out. So if we have that many glucose molecules, we have 1 mole of glucose over how many kilograms of solvent? Well, if we have 0.98 liters, that means we also have 0.98 kilograms of water. So we have 0.98 kilograms. Okay, so now we have 1 mole over 0.98, and that is going to be around, so this symbol means it's not exactly equal to, but it's relatively similar to, and I'm actually going to pull up and calculate it here real quick. 1.02. It's about 1.02. Okay, so for 1 mole of glucose molecules in 1 liter of water, that is a 1 molar solution. So you would say 1 m glucose solution. However, if you took the 1 mole of glucose outside of the 1 liter solution that you have, bring it down to 0.98, that would mean that you have 1.02 molality of glucose. So, main difference here, molarity, moles per liter, molality, or little m, moles per kilogram. Okay, make sure you listen for that L versus that R. Please like and subscribe if you want to see more videos like this. If you have any questions or any videos you would like me to make, please comment below so that I can address the topics you want focused on.